Hello everyone, welcome to Analyst Chronicles YouTube channel. So the purpose of creating this channel is to explore the some data sets using Python. Today we are going to explore one data set which is very familiar with everyone, which is IPL dataset. So I'm going to explore this data set and we are going to see from the first season where it started in 2009 to 2023 season. So I do not have the data for this ongoing season. Uh, but I have the data set till 2023. So we can do some analysis and we can see. So the main motto here is like, so how can we do exploratory data analysis with Python or with Python pandas? So we are going to see here. So if it is useful or if you are learning something out of this video, please do subscribe the channel. So if you are familiar with the Python libraries while doing the data analysis, so we must import a few libraries which are already inbuilt libraries with Python. So the useful libraries are like first one is like importing NumPy as NP, so which is nothing but a numerical Python to do some numerical operations. So we need to import NumPy as NP, and the most popular and most important library is like Pandas as PD. So Pandas is a very important library to do some data analysis. If you wanted to read the existing data from Excel sheets or from a CSV file, it could be any file. So you need to use Python to read the data. And even if you wanted to do some analysis on the like data cleaning, it could be like filtering or sorting or extracting something from the data. Or if you wanted to see some insights in the data, you must import the library called Python. So it is very useful and in fact a powerful Python library. So that is one thing. And the second is importing matplotlib dot pyplot as PLT. So this is matplotlib is like if I wanted to visualize the data, whatever I analyzed, I just wanted to show the insights from the data with a graphical representation. So I have to import matplotlib. And we do have another library called Seaborn. So this is also a visualization library from Python. SMS. I'm also importing datetime. Okay, so and also sometimes we may get some warnings like the old uh, command is not going to use in the coming version, something like that. We may get some warning messages in the script. So if I don't want to see that warnings, I'm just importing warnings as well. I don't want those warnings. Okay, so okay, something is wrong. Okay, see once. Okay, warnings. The warnings, warning, filter warning. What is wrong? Mental warning. Warning stop. Filter warning. Skipping. Oh, sorry. Yep, skip. Okay, so now we have successfully imported our required libraries. So let me read the data. I'm just calling my data frame as df, and then read and this case CSV file since the raw data is in comma separated values. So yeah. So the code to read a CSV file or to a Excel file is for, so for example, my file is in CSV format. So I have to use CSV here. So apart from this part, and the other part is same. Like if I wanted to read a Excel file, here you should write Excel. So like that. So since I'm using or my data is in comma separated values, so I have to use pt.read underscore CSV. So I'm successfully imported the data into the Jupyter notebook. So I just wanted to see the shape of data. So to see the shape of the data, shape nothing but so how many rows and how many columns we have in the data. So it is we have 2,43,817 rows and 23 columns. So this is so with this command df.shape, we can able to see the shape of the data. And I just wanted to see the information about data frame. So df.info, it will give us the information about all the columns. So here you can see, and also the good thing about this df.in info function is like you can see the column with null values as well, and also a data type of that particular column. So here, so since we have 23 columns, always the indexing starts from 0. So if our first column is like match ID, and we have 2,43,817. So there are no null values in match ID, and it is in integer format. And object means it could be in categorical category or sometimes combination of int float or categorical cat data. So that is why here it is showing as a object data type. And you can see, so till extras season, so how many seasons, and the start date, venue details, innings, ball, like first ball, second ball, third ball. So you can see we have the data, ball to ball data here. So that is why we have 2,43,000 rows. So I have the data from the first ball of 2009 first IPL season to 2023 final ball data. So this is batting team name, bowling team name, and the striker means who is striking, and non-striker bowler runs off the bat, and if there are any extras, it will be there in the extras column. So till here, from match ID to extras column, we do not have any null values, whereas we have some null values from voids. See, out of 2,43,000 rows, we have only 7,652. So obviously, there are few voids. So that is the reason why apart from so if I take from first season to 2023 season, so we have around 7,652 white balls bowled, and no balls are like 1,018, and leg buys are 628, and this is normal buys, and leg buys are 3,778, and penalty wicket type. So we have all the columns. So the importance of this df.info is like I just wanted to see the column with the data types, and if there are any null values, we can see the null values as well. So first thing I just wanted to see the head of the data, df.head. So it will by default it will show us the first 5 rows of the data. So here you can see. So here you can see some dots, right? So if I wanted to see all 23 columns, I have to write another code which is pd dot set option display dot max columns. Okay. So basically, it will show us all the columns. To here, for example, I have 23 columns, but if I wanted to see the head of the data set, here I'm not able to see all the columns. A few columns are hidden, so I don't want to see anything like this. I wanted to see all 23 columns. If I wanted to see all the 23 columns, the function is called. You need to write pd.set option. So you need to set the option as uh, display dot max columns. So now if I run this code, so now you can see all the columns. There are no dots, there are nothing hidden. So here I have the top five rows. So as I said, I have the data till 2023 final match. So top rows are like first ball of the 2023 season, which is happened on May 29th of 2023 in venues like Narendra Modi Stadium, Ahmedabad. And the batting team is Gujarat Titans and bowling team is Chennai Super Kings. And the striker, opening batsman, striker is Wriddhiman Saha and non-striker is Shubman Gill. So we have this data. So you can see uh, runs of the bat, extras, wides, no balls, buys, leg buys, penalties. So for example, from the first ball, I mean it is a dot ball, so that is why runs of the bat is zero and extras also zero. And why I'm seeing this NaN, not a none or not a number. So this obviously it is not a wide, it is not a no ball, it is not when we did not get any buys or leg buys. So that is why these are all filled with NaN values. So if it is a wide, then you can see how many runs came out of this from wides. For example, sometimes you can get one run or you may get five, four or five wides if it is going to the boundary. So the respective numbers will be there in this column. So and the no balls, how many runs from the no ball, buys, leg buys, penalties. So wicket type. Wicket type means it could be a bowled catch out or a thumped run out. So you can see this kind of data here. And player dismissed and the batsman name who dismissed, who got out, and other wicket type. So these are all the description about all the columns. So this is for to know, I mean, to show the first five rows of the dataset. And I do have another function which is df.tail. It will show us the last five rows of the data. So you can see the last five rows of the data here. Mm, Now I wanted to see is there any null values in the data set. So obviously you can see here NaN means not a number. This is a null value. So all these are null values. So I wanted to see how many null values are there in the data set. So there is a function called df dot is null. So if you just write df dot is null, you will get a data set with uh, true false statement, which is like with this type of command, you're not going to understand. So, which is a Boolean statement, like if there are null values, you can see true, and if there are no null values, and it will be replaced with the false. I don't want to see like this. I just wanted to see the number of null values in particular column. So to know that, dot sum. See now you are able to. This is much clear if I compare with the older command. So this is match ID. So as I said earlier, till extras we do not have any null values. So from whites, we do have a lot of null values. So I just wanted to fill this null values because sometimes if I wanted to do some analysis, I mean, you will get some error because of this null values. So that is why I wanted to fill the null values with 0. So sometimes if you are analyzing a different data set where null values are present in categories like true, false, or male, female, something like that, you can replace those columns with mode of that particular column, and mean also according to the situation. So if it doesn't disturb the distribution of the data, then you can uh, fill the null values. So as per the requirement here, I just wanted to fill NA. So the command to fill the null values is like fill NA, and here uh, it is df dot fill NA, and here I have to give some value from which value I wanted to fill. I wanted to fill all the null values with a 0, and in place is equals to true. That means I wanted to apply these changes to the original data set. If I don't put this in place is equal to true, here I will get the data with filling the 0, but that is not applied to the original data set. So I have to use this a function called in place is equal to true. Then the modifications or changes will be applied to the original data set, which is df data frame. Execute it. Now I just wanted to see is there any null values. See, now it is all the null values are filled with a 0. So there are no null values now. Now I have the data with 0 null values. So now I wanted to see the head of the data frame. See, previously I used to have this after extra wide 0, 0, 0, 0, 0, all null values are filled with 0. Okay, so let's do some analysis. If I wanted to see what are all the categories under wicket type. So as I said, it could be about a run out or run out summed. So if I wanted to see uh, categories in this particular column, you need to use value counts, value underscore counts. Then you can see all the categories. 0 means just now I filled with none, right? So there are 2,31,750 rows. Uh, because obviously all each and every ball we do not get a wicket, right? So that is why we have a lot of null values or zero column. So we have 7,437 catch outs, and bowled is like 2,000, around 2,000, run outs are 1,000, LBW wickets are 750, and catch and bowled is 343, stumps 345, retired hurt. So you can see all the categories, category wise data for wicket type. And if I wanted to see the same thing for seasons, obviously we know uh, season, same thing, season dot value counts. See, from 2007, so it was in decreasing order, so that is why we have randomly updated this data because I have 18,177 rows for 2013 season, and if I compared with the 2023, the number of matches has been reduced because I think 2013 we may have more matches, or it could be new like the Gujarat Titans. So other teams are placed. That is the reason why I have larger data for 2013. And from 2020 to 20, 2009, 10, 21. So we have almost similar data, like 14,000, something like that. So it also depends on the number of matches. So if the match is uh, for uh, for one innings has 120 balls, if I include any wide or any no balls, so it could be around 130 plus. So the data will be different season to season, and also match to match. It could be more, it could be less, depends on the match, how it went. So that is what I have season and the number of data values in that particular season. So this is value counts is basically if I just wanted to know the category wise data. Okay, if I wanted to see the description of the data set, which is like df dot describe, so it will show us all numerical columns. So it will not be applied for any categorical columns. It will be only for numerical columns like match ID, season, innings, ball, and the number of runs from the bat. Because describe function, it will give us what is the number of rows present in that particular column, and what is the mean of that column, standard deviation, and the minimum value, 25 percentage quantile, 50 percentage quantile, 70 percentage of quantile, and the maximum number in that particular innings, sorry, particular column. So if you see the number of runs of this bat, the mean value is like 1.25, standard deviation is 1.62. There is no minimum, I mean, minimum value is zero, because if there is no run out of that particular ball is like obviously zero. So we cannot see any negative values here. And the 25 percentage is also zero, 50 percentage of ones, 75 percentage of ones, and the maximum value is six. Maximum runs we can score from a ball is like six. So that is what if I wanted to see all count mean, standard deviation, minimum, maximum, 25%, 50%, 75% of the contents. So you can see apply this df dot describe function, then you'll be able to see this thing. And so we can apply some conditions as well. Let's see df dot head. And now I wanted to see 10 rows, then I'm putting 10 here. So I got the data with 10 topmost rows. So if I wanted to get only two columns, I have 23 columns. I don't want all 23 columns. I just wanted to have only uh, the season and the batting team, bowling team. I just wanted to see only few columns. So how to get or how to achieve that, or filtering the required columns. So you need to mention that particular columns inside a list. I wanted to have a season column and batting team column. And if I run this, then see, I have the data entire 2,43,000 rows, but this time I have only three columns, because sometimes we don't need all the columns. So if you can see, almost from white snowballs, the data is not present. So wherever it required, it is there. It is updated with that particular number. And if I wanted to see some analysis like seasons, and I just wanted to see the batting team and bowling team. And I just wanted to filter it out with a season or something like. If you wanted to filter the data with the required columns, then you can use this code to get the required columns data. There's a one more interesting thing like correlation. Df dot correlation to see the correlation between the columns, numerical columns only. This is again, so you can see the correlation here. So to see the correlation, df dot corr function to see the correlation between the columns. Okay. Now we will see some interesting stats out of this data set. So first, is there any duplicate values? We must check. So to see the duplicate values, df dot duplicated dot sum. It will show us the number of duplicated values. So just like null values only. So if I remove this sum and if I enter this, I'll get again Boolean function. If there are any duplicate values, it will come as a true value. If there are no duplicate values, then it will come as false. With this data, I'm not understanding anything. So if I put sum, it will give us some of the duplicate values. So entire data set, I have only two uh, duplicate values. So if I wanted to see those two values, hmm, so these are the duplicate values present in my data set. So I have to remove these duplicates. Df dot drop duplicates. Again in place is equal to 0 because I wanted to apply these changes to the original data set. Drop duplicates. Okay. So my original data set has is 243,817. So now after deleting duplicate values 15. So it was earlier 17. Now two rows got deleted. So that is why we have 243k rows present. So if I wanted to see the batsman wise striker, so top scorer from first season to 2023 season. So to know that, I have to the striker dot. You can see the data batsman wise number of. So I think this is not giving us accurate data, so we can use group by so that you can able to see the striker and runs of that. So the problem we did not get the accurate data is like with the value counts, I can able to see the number of rows. So for Virat Kohli, I have 5,739 rows only, but that is not exact runs. So I wanted to see how many runs Virat Kohli has scored. So to see that particular data, I can get these details by group by function. I can group two columns and I can get the required data. So for example, I'm grouping striker column with the runs of that, and the aggregate function I'm using is sum of the runs I wanted from runs of the bat, and it is ascending order. So that is why you can see A to Z, and I just wanted to sort value, sort values. Hmm. So now it is working. So you can see, and I just wanted to see the top 20 batsmen or top 20 or 10. Let's see, 20. Hmm. So, so as I mentioned, this data set has a value till 2023 season. So I have Virat Kohli with 7,273 runs and Shikhar Dhawan with 6,617 runs, and the list goes on. So top 20 batsmen from first season to 2023 season. So you can see the day number of runs scored by each batsman. So this is how you can see the data. So so this is how you can analyze the data. So in coming videos, I will take different data sets. I'll try to visualize the data as well. So this is the first video. So I just wanted to show some basic commands by using Python Pandas. So I hope it is helpful for someone. So if anyone has any questions, you can comment on the video. So that's all for today. Thanks everyone. Please subscribe the channel. Thank you.